All right, this is problem number 36 on page 347. We're in chapter 6, section 3, the integration by parts, or tabular integration. And hopefully the assignment's been going well. And then you come to a problem like this that says true or false. If f prime of x equals g of x, then the integral of x g of x dx equals x f of x minus integral of f of x dx. Justify your answer. And initially it's like, what is this problem asking? Well, you know we're doing integration by parts, so you think of your formula for integration by parts. Integral of u dv equals uv minus the integral of v du. And you look at that, and you look over here at this formula and say, oh, that kind of looks the same a little bit. And maybe specifically you look right here and you think, oh, I wonder if x is u. And then maybe this f of x is our v or whatever. We'll figure that out in a minute. But maybe because it's this x, f of x, we'll begin with this idea of, let's start here on the left side. Let's take the integral of x, g of x, dx. Let's take that integral. How would we take that integral? I don't know. It's a product. Let's try integration by parts. And again, I don't know what g of x is, so I'm going to kind of ignore right now the Lipit acronym, and I'm just going to go right away, and I'm going to let u equal x. If u equals x for integration by parts, then what does dv equal? It equals whatever's left over, which is g of x dx. All right. Under the u, I'll take the derivative. The derivative of u, the derivative of x, is 1 dx. So far, so good. And v, I need to take the integral of g of x. So I've got to take here the integral. I come up here to the top when you're giving me this information. I'm going to take the integral of g of x. But g of x was f prime of x. So I'll take the integral of this side. Say, wait a minute. The integral of a derivative is the function. So it turns out f of x is the integral of g of x by the fundamental theorem. So we took the integral of both sides, this side and this side. On the left side, the integral and the derivative canceled out, giving us f of x is the integral of g of x. So I'll use that little piece of information right over here. V equals f of x. And now I plug this into my integration by parts formula. So the integral of u dv equals, here we go, uv, which is x, f of x. Oh, I like this so far. Oops, minus. So x, f of x, minus the integral of v du. Well, here's v, f of x. Here's du, dx. And that looks exactly like the formula up here. So we would answer true. Our justification is what we've just given. Letting u equal x, applying integration by parts, we get the identical formula as mentioned in the question. This answer is true.